Yeah, good morning, friends. So, in the last lecture, we have started with this particular topic, earthquake monitoring and measurement. I will just take some of the glimpse of my last lecture and going ahead. Uh, let's see. So, in the last lecture, we have discussed for the measurement of the earthquake, we are using two different parameters. One is intensity and other is magnitude. When I'm saying intensity, as we have said, intensity is the relatively a qualitative parameter which depends upon the particular earthquake, how it is being feels to the observer. And as you know, the observer's observations may be different, and that is why I'm saying it is the qualitative parameter. So as we have said, it is a qualitative assessment of the kind of damage done by the earthquake. Second, we have seen, which is it depends upon the distance to the earthquake and the strength of the earthquake. As the bigger earthquake, the intensity nearer to the epicenters may be higher, and as you progress along the distances, the intensity of same earthquake will probably reduces. Third thing we have seen, that is it determines from intensity of shaking and the damage from the earthquake. So during an earthquake, how much shaking is going to be observed? Here this intensity and this intensity is different. This is, I mean, for intensity of shaking, means what amount of shaking will going to take place. This is called as, so it depends upon this, and also whatever the damage is going to take place. So this is all about intensity. Magnitude we have seen. The magnitude is the another parameter through which we are measuring an earthquake. It related to energy release. As you know, during the earthquake, once the earthquake happens, it releases a lot of energy, and if you measure this energy based on this particular measurements, the earthquake magnitude will comes into the picture. This is a quantitative measurements, very important. It is a quantitative measurements of amount of energy released by an earthquake. So in comparison with the intensity, magnitude is probably a more reliable parameter to measure an earthquake. It doesn't depend upon the observer's decisions, but it is the analytical value which determines from the amount of energy which is released during the earthquake. It is also depends upon the size of fault that breaks, means it depends upon the rupture area of the fault. It determines from the seismic record, whatever the records you are measuring, I mean whatever the earthquake you are measuring onto the seismograph, from that record you can actually determine this particular magnitude. We will see in detail everything. Now I have just taken a typical map in the area of San Francisco. You can see this, where the intensity scale is being measured. You can see here the intensity is ranging from 1 to 10 plus, right? So these are the number of, you can see the segments that has been made to see a different intensity at the place. You can see somewhere here at this location, the color is very dark. You can say this is probably the intensity is very large. You can see here is the fault line where the earthquake happens. This is a location of an earthquake, and how this intensity has been actually transferring. You can see here is the maximum intensity, and as you are going across, if you see the contouring, probably you may be able to see that the intensity of an earthquake is been reducing as you are progressing from the distance. Now this particular type of map is having a particular name which is being called as isosismal maps. Whenever you are going to plot an intensity on a map, it is called as isosismal maps. Okay, so this is a kind of isosismal map, and the Mercalli intensity is being plotted. What is Mercalli? We will also see in detail. So the maximum intensity is used to estimate the size of historical earthquake. This method is not accurate because it depends upon depth of earthquake. Also, it depends upon population, construction practice, side effect, regional geology, so many things. So damage is just not alone. The damage is also depends upon so many parameters. For example, I've given this example last time. Just imagine the Ahmedabad 50 years back and Ahmedabad now. If you just imagine, if the earthquake happens 50 years back, and if just assume the damages in the Ahmedabad, and if earthquake happens right now, same earthquake, and just imagine the kind of damage happening in Ahmedabad, which is entirely different. Nowadays, the risk in such cities which will be very, very high because of increase in the population, increase in the typology of the construction practice. Before that, we used to rely on more of a tenement or bungalow type of buildings. Now we are relying on vertical buildings like flats. And so that you can say that the risk of a particular area is being tremendously increased because of the population which has been lies. At the same time, you also consider the type of geology that has been exist. As we have said, the soft soil will produce a more long period ground motions, and probably it will affect to the high-rise buildings, and the short period which is nearer to the epicentral regions, which generally affects to the low-rise buildings. So the regional geology is also going to play a bigger role in the damage pattern of an area and to the intensity. So these are all, you can see, the very, very important parameter while we are considering intensity. However, this measurement is not been actually reflected in actual intensity measurement. It is just the observers that is been observing how the damage is being felt. We are recording those decisions, and we are plotting, you can see, the intensity values. Now let us go further. How strong the earthquake feels to the observer. Just imagine yourself. First is the distance to the earthquake. Suppose earthquake happens in Bhuj. If you are at Ahmedabad, if you are nearer to the Bachau or Gandhidham, so Gandhidham is nearer to the epicenter, probably you will feel more intensity, more shaking, and probably you will say that I felt a very strong earthquake. At the same time, there is a further location, probably if the observer feels, then he will have a moderate or the less effect of the same earthquake. So it is depends upon the distance from the earthquake. Second is, as I explained, the geology and the type of buildings and observers. If see there is a number of observers sit at the same place, still their observation might be different. Some is saying I felt very strong, some may say I do not feel that strong. So that is also a possible. So it is also hampering, you can say, the intensity values. Now, if I just go in little bit of history of this intensity scales, how it has been developed, then I will say that the first classification of earthquake intensity is been derived in 70-80s. Just imagine. The first intensity scale in modern sense of the word has been drawn up in 1828. After that, first widely adopted intensity scale officially by the technical forum is the Rosie-Forel intensity scale, was introduced in late 19th century. Since the numerous intensity scale have been developed and they are used as a part of the world. After that, there is a most popular, that is a Mercalli scale has been originated with widely used Rosie-Forel scale. Generally, Rosie-Forel has been used in the European countries. Then after the Mercalli scale will comes into the picture, which is widely adopted by the scientific community. Unlike the magnitude scale, the intensity scale do not have mathematical basis. They are an arbitrary ranking based on observed effects. Most of the seismic intensity scale have 12 degrees of intensities, right? I'll just show you one example. This is the setup of modified Mercalli intensity scale. Just see here in the left side, you will see there is a 12 different divisions that is being made, and with each divisions we have linked with observers observations. So first, if you say, suppose you somewhere and you felt like earthquake is being detected by some sensitive equipments, it is not been felt by any observers, then you can say it is the intensity scale of 1. Similarly, if it is felt by few persons, right, felt by few person at rest, he is in the standing position or rest position, especially on the upper floors, delicate and suspended object may swings. If you feel such type of observations, then you may say that this is the intensity scale of 2. Similarly, if you see this is the third notation, it is being felt by noticeably by the indoors, especially. Please mute your videos. Please mute your videos. Third, it is quite by indoors, especially on the upper floors of the building. The vibration is likely like a passing of the truck, and the duration of an earthquake may be estimated. However, many people do not recognize it is an earthquake damage. In such condition, damage will be no damage. Standing water may rock. So these are some of the observation which is being clubbed. If you feel any of such observations, then you may actually you can assign the intensity scale of 3, and so on. There are 12 different observations is been linked. I will just read some of the observations. You may just realize that how this intensity scale is being increased and how it is being linked to the higher order of observations. Like for an example, if I read intensity scale of 8, you will see slight damage in specially designed structures, considerably damage in ordinary substantial buildings with partial collapse, great damage in poorly built structures, panel walls are thrown out of the frame structures, there is full of chimney, there is a fall of chimneys, sorry, factory stacks, columns, monuments, and the walls. Heavy furniture is overturned, sands and muds are ejected in the small amount, and there are changes in the well water conditions. Now, just go towards the intensity scale of 11, which is quite high. Damage is few, if any. Masonry structures remain standing. Bridges are destroyed. Train rails are generally bent. They are a broad fissures in the ground, and underground pipeline are completely out of services. They are earth slumps and landslips in the soft ground. Similarly, the 12th, which is the waves are seen on the ground surface, line of sight and the level are distorted, damage and the total damages, practically all works of construction generally damaged and destroyed. Objects are thrown in the air. So this is a complete damage observations, right? Okay. Okay. Now let's go further. Once you do this, then we also need to see, so this is basically what I've discussed, which is the modified Mercalli scale. This modified Mercalli intensity scale we are also using in Indian conditions at present. At present we are using, you can see the modified Mercalli scale in India, right? So, and also in several countries is also adopting the scales worldwide. If I talk about a magnitude, I will divide this magnitude into the 4 different categories. The first comes, which is ML, which is L is suffix is known for local magnitude, or you may say it is the Richter magnitude. It is also very popular whenever we are saying an earthquake magnitude, which is always we are saying what is exactly the Richter scale in which the magnitude has been measured. So this is nothing but ML is nothing but local magnitude or the Richter magnitude. The second which comes, which is MS. S is for the surface wave. So this is the surface wave magnitude. And third one is the MB, which is the body wave magnitude, in which you are measuring the body wave or the P wave onto the seismograph. MS is the surface wave, as I said, which measures the relief waves on the seismograph and predict the magnitude. And the fourth one, which is very, very common, widely adopted in most of the countries, so that is the MW, which is the seismic moment magnitude. Whenever I am using just a magnitude, it means it is the seismic moment, because generally we will convert all this magnitude into the finally the seismic moment magnitude. We will see one by one. We will see it's how it has been calculated, how it has been, what is the limitation of each, and so we will see one by one. Okay, let's see here. First is, you can see this, a seismograph peak amplitude. The peak amplitude is nothing but a size of largest deflection from the zero line. Zero line is somewhere here. You can see this is a zero line, and you can see this is the largest deflection. So this is probably a largest deflection from the zero line. So this is my peak amplitude. If earthquake happens here, and if I'm measuring with number of seismographs like 1, 2, 3, and in each seismograph I can able to record such type of peak amplitudes. With this basic understanding, I'm just going to see what is exactly the Richter magnitude scale. So Richter is a Charles F. Richter have given this particular magnitude scale. The magnitude of earthquake is determined from logarithm of amplitude of the wave which is being recorded on the seismograph. Okay, adjustment are included for the variation in distance between various seismograph and the epicenter of the earthquakes, right? So this is the second point, very, very important. On the Richter scale, magnitude is represented in whole number and decimal fractions. At first, Richter scale could be applied only to the records from instrument of identical manufacture. So this is a limitation. The Richter is used a seismograph of a particular manufacturer, and its Richter scale is only applicable to that particular seismograph. So that is a limitation of the Richter scale. Now instruments are carefully calibrated with respect to each other, and thus the magnitude can be computed from the record of any calibrated seismograph. I will just go in the detail. Okay, this is what the logarithm of peak amplitude that has been computed for various magnitudes, and this is the distance. However, just this is for your information. This is what the graph he has actually developed by several measurements, and then it forms the formula. Now there are another various salient feature of the Richter scale. The amplitude scale is logarithmic, number one. Second, the earthquake energy, each whole number represents 33-fold increase in the energy. Energy difference between 3 to 6 means it is 100 times. Means if I'm saying my magnitude of an earthquake is being increased from 3 to 4, means whatever the energy is been released in the magnitude of 3 earthquakes, which has been increasing by almost 32 to 34 times or 33 times in the magnitude of higher order, that is magnitude of 4, and so on. If I say magnitude from 3 to 6 means just 3, 33, 33, 33, and so on. So it means multiplied almost 1,000 times. So as I said, this particular Richter scale or Richter scale is being used for only particular type of manufacture of the seismograph, and it has been so that seismograph has been developed by Wood and Anderson type of seismograph. So only Richter scale is applicable for this Wood and Anderson type of seismograph only, and that is what his limitation is. Second is the measurement past magnitude 7 is ineffective, which requires the estimations. Means the ML scale or the Richter scale not be able to measure the earthquake which is beyond magnitude of 7. Now, third, Richter used the observations to construct first magnitude scale, which is ML, in Southern California. He is based on his formula for calculating the magnitude on astronomical Brighton scale, which was logarithmic. Let us see what is that. I will just go in a particular detail how this. So this is a Wood and Anderson type of seismograph, what he has used, and based upon that he has developed certain you can see the earthquake history. Just for your information, I am putting it. Richter scale is valid for Southern Californian earthquakes. It is valid for a particular seismograph. Has not been used by the professional seismologists in decades. It is much criticized. We will see this thing like if you want to measure the Richter scale, he has given this particular formula. ML is equal to log of A in mm, right? A is nothing but it is the maximum magnitude plus 3 log 8 delta t seconds minus 2.93. This particular formula he has given from this particular map. See, I have shown this map. By analyzing this particular map, he has actually developed this particular formula from the regression. So we will come here. Now see how this A will be calculated. So if you see, suppose this is a history which has been recorded in Wood and Anderson type of seismograph, and you can find out this is the amplitude, which is 23 mm. So you can say this value of A is 23 mm. Delta T is another variable that you can find it out from this. That is the time of arrival of P and S wave difference. So if you see, this is the P wave is reached to the seismograph, and this is the time at which the S wave is reaching to the seismograph. If you take the differences, then you can say this is a 0 time. This is almost a 24 seconds. So 24 minus 0 is 24 seconds. So delta T is 24. If you put this value and whatever the value of ML is coming, that is nothing but the Richter scale. So this way you can calculate the value of Richter scale from the recorded value of seismograph. He has also given the monogram to find out the Richter scale value. If you see, this is the monogram has been placed, in which you can see on this side, on this axis, there are 2 parameters has been placed. On right hand side, there is a P minus S seconds has been put here, and distance from the epicenter is been put on this axis. Middle one is showing different value of ML, different value of Richter magnitude, and third is the amplitude axis is been plotted here. So if you know any of this parameter, if you know the distance of seismograph from the epicenter, or if you know the difference between P minus S, you can calculate from the seismograph recording, either of these two. If you know the amplitude, this is also the parameters you can calculate from the value of seismograph. Then let us assume for this case, suppose I have assumed the P minus S is 24. So this is somewhere here. And the amplitude you have found out, maximum amplitude you have found out 23. So which I have plotted here. And if you draw a straight line which passes through this middle axis, then the magnitude of this particular earthquake is somewhere 5. This way, from this monogram also, you can calculate the value of Richter scale. If you do not want to use this monogram, then you can use this particular equation, which is a similar, both is similar thing. So you can use this equation to find out the ML, right? So this way, you can actually find it out the value of ML. Some people have also tried to compare this magnitude scale with the intensity, and they have also put this intensity scales with certain observations. Like magnitude 1 to 3, it is recorded on the local seismograph but generally not felt. 3 to 4 is often felt but no damage. So these are all the observation of the intensity, but it has also been linked with the magnitudes. This is a very good table. I have found it from the literature and I have used in many of my research to validate my values, in which you can see this is a local magnitude is being given. This is the typical value of amplitude in terms of acceleration, which is A max is being given. This is typical duration of the ground shaking. Whatever the duration of the ground shaking in seconds is being given. And these are the modified Mercalli intensity scale is being given. Now, if you want to find out any of these things, like suppose you have assumed that somewhere the value of, you can say, acceleration is somewhere 0.09, you can imagine there will be a magnitude of 5 earthquake, right? And its duration is very, very less. As you are increasing, you can see these values, probably the duration is also going to be increased. Similarly, the amplitude is also going to be increased and the intensity is also going to be increased. This particular table is used for validations, or sometimes it will give you a rough idea during the particular earthquake how much the amplitude will be generated or what will be the intensity at different locations will be generated, right? So this is a very simple table is being given. So as I said, this is the exactly a correlations with the severity index of damages is been also given. So this is what about an intensity scale. So I'm just stopping here because so this I will carry forward. Like for example, whatever the limitations of ML scale or the intensity scale, we need to take it forward in other magnitude scales, because this, as I say, the limitation of this particular scale, first, it is applicable only for Wood and Anderson type of seismograph, and which should not be the case, right? For any other seismograph, you can actually analyze and you can find out, you should find out the magnitude scale. So that is the biggest disadvantage of the ML scale, which will be, we will taking care by the other magnitude scale. We will see it in the next lecture. If you have any questions, you may actually put in the chat box. I'm able to actually answer it. Thank you very much.